Hi guys, welcome to Balkan Shipyards, freestyle Vaka Building. So can you build a boat? I bet you can. You know what? 10 years ago, I thought I couldn't build boats. I always wanted to buy a design from somebody because I thought I can't design them myself. Yes, I messed up quite a lot over the past 10 years, but this is my fourth build and I don't know. I got a good feeling that I know what I'm doing. My last boat is real good and anybody can build a boat, but you have to think boats. Okay guys, so think boats, build boats, and you know what, if you build a proa and you become a shunter, then you're in business. All the best guys, keep shunting. Balkan Shipyards, here we go. Welcome to Balkan Shipyards. Vaka behind me, Ama in front of me. This is a 6.7 AMA, 6.7 meter AMA of the HAVAYA 3025. That's the dagger board. This dagger board is 1.8 meters long, but only that section goes down into the sea, which is 1.2 meters by 50. So that's 3% of my sail area. So that should be enough. It might be a little bit too much, but it is what it is. We go with it. So that case has to get mounted in. Little bit of a flat bottom in the middle and V bows. Beam length ratio is 1:18 on this AMA. And there's the Vaka. So the Vaka is 7.35 meters. It's about 24 feet. And over here, beam to beam length ratio is 1:10 at waterline in the center. So lake to aft, big time. I like this. I like lake. There's a lot of flare on this hull, and there's a lot of bow over here. Here's the hull itself inside. 117 max beam at the top, and then there's going to be another meter of leapod that comes out to here. So in order to get all that to work, there's going to be trusses and bulkheads and all kinds of fancy stuff inside this hull. I'm going to try and keep things as light as possible. Crystal clear. I made her so heavy I built her like a tank. I went overboard with her, and then why not, I built him as flimsy as can be, and he was the best in the West. And then this thing up there, that's a ratio beam length 1.7, 1:7. He's very wide canoe, and he's also flimsy. And you know what? Pros are strong. Pros are strong stuff. 8mm poplar ply, and again 8mm poplar ply. Now we start working inside with 6, with 5, all kinds of stuff. Epoxy primer for steel, 2-pack, the best in the West. And then on top I got my white polyurethane acrylic, 3 coats of that for sure. I don't really remember if I put 2 primers or 1, but a minimum 4 coats, maybe 5. And this is how this hull's going. I'm not fiberglassing it inside. I'm just going to look after it. I don't need this hull for long. I need to prove the concept, and we need to test the boat, and we need to see how far we can go and stuff like that. And if this boat lasts a year and a half or 2, it's more than enough. Guys, before we go on to the Vaka build, please let me say something. This channel is not monetized. There's no adverts. You don't have to wait 5 seconds for the advert to go away and stuff like that. There's nothing of this stuff. I don't want this stuff, okay? We're not making money over here. It's about promoting the pro. It's about bringing back the best of all boats. Shunters must come back. Shunters are the best. The strongest of multis, the stablest of monos. Guys, please give us a like, subscribe, share. Please share. It's all about sharing, okay? There's information over here that can help people build boats. I always wanted to build a boat. I always thought I can't build a boat. I always thought I got to buy an expensive design from somebody. I always thought you have to build them in the most expensive way. No, there's a freestyle way to do things. All the best, guys. Give us a like, subscribe, hang with us. HAVAYA 30, 25 from Balkan Shipyards. Keep shunting, guys. The force is with you. So this is how I closed the bows, so I could put in the stems. I just tie the rope around. I put in small screws so they stop it from not sliding forward, and that tightened the bow really nicely so I could put in my stem. And then I screwed it on over here with small screws up to above waterline, way above waterline, and then at the bottom I'll clamp it. So tomorrow I'll start gluing the stem in and fill it in it. It's going to get all filled up with epoxy everywhere, and then a piece of glass going over. So it's got to get tightened up at the bottom, like I said. Yeah, I'll show you the stem from the front, and you can see the flare. I wanted more flare, but I got what I got, and that's what I got. Here's the hull. So, not bad. Could have got more, but then I'd have to make it out of 2 panels, and I didn't want to do 2 panels. I just wanted to have sidewall, one sheet of ply running all the way from the top to the bottom. I'm trying to simplify the build. I'm trying to just make a simple, fast type of a proa, and I'll see how it works. Might work well, might not. I don't know. I believe it will work well. Let's hope it does. And it's the point is about, it's just cutting down on labor and cutting down on complications, and I'm not looking for a very fancy hull. I'm looking for a hull that will just get me from A to B, you know. Cruising speed, if I can cruise at like 8 knots, I'm very happy. I mean 7.5, 8. I'm not expecting all these 12, 15s, all these fancy speeds. No, I don't need that. I just want a cheap boat and a fast build that can go a long way. Here's how I fiberglass the bows. So I put in a stem. Here's a pine stem that is 3.5 centimeters at the top, and down there at the bottom it's 1.5. So the bow's opening up. Later on we're going to put a whole piece in the front and round it off nicely, glue on a whole piece. So it's been, the way I did it was I put it in, and then I put thickened epoxy down on the sides, and I filled it up with little pieces of wood that I shaped and made them into like sharp, and I banged them in, and the epoxy was squishing out everywhere, and I really packed it really well, and basically it's done. And then I came with 350 gram glass, and I went all the way from here to here to here. So flipped over the hull. Now we start working on the bottom over here. I've got to even these guys out, plane them until it's flat, and I have to put in a few more of these things over here, split it out so it's all the same. And basically any piece of flat wood is good. So this would go here, for example, and this has to go until it's lying flat and there's no gap over here and over here. It all has to come down. So I spread out the hull the same, so it's all perfect. And now I'm working on the template. I'm making a quick and dirty template, so I'm not putting in too much effort, and I'm going to make it the whole length. Then I take that template and I put it onto this sheet of ply, and I start getting out the bottom. There's going to be there's going to be two butt blocks on the length of this thing, so it's going to be made of 3 pieces. I don't know what this is. I bought it from Welder, where I buy all my poplar. I believe it's a poplar core, because it looks poplar. It's white core, and then it's got like kind of an okume on top of it. I don't think it's okume. I don't know where it is. They can't tell me. They gave me all kinds of Bulgarian names. I didn't understand what they were talking about. But basically, zero voids and glued with phenol formaldehyde, the way I like it. So this is exterior grade, top quality, really nice stuff. In the middle, the max beam of this is 30 centimeters, so that 12 mil is going to be super strong. Here's the full template over the sheet of ply, and basically I've marked the center of the ply and the center of the boat. So I measured, marked the line, I put the line on the line. Now I'm just marking this side. I've marked it already. That's the cut line. I cut this, and that's the middle piece. And then I'll just add on this piece and that piece. So from this line to the end is the piece that has to get added on over here for the bow. Now, because it's kind of risky, because I'm going close to the edge, if I mess up on angles and stuff, the piece can run off and you get really messed up. So it's wiser to cut these pieces slightly bigger. So what I'll be doing is, I don't want to waste ply either, so I'll put it on the line kind of, so it's just in the ply, yeah. And I'm going to leave myself that much on both sides spare, so I can sort this cut out on the boat itself and get it to match perfectly to the piece I've mounted already. This piece has been mounted with 4 screws, really small screws. I put them in, one here, one there, and 2 on the other end. And now I'm cutting this piece wild so I can wiggle it and woggle it until I get this perfect cut to match and close up. So look at this ply, 0 voids. Amazing stuff. So here's what I was talking about. So now when I put this bucket up with this, it's running off over there. Now, piece of cake. I just have to cut this on the chop saw. The minute I cut it at the right angle, it will close up and it will cover the boat on both sides, and we're ready to go. Do the same thing the other end, and it's done. Here's the bottom, bricks, butt block, and again polyurethane glue. Yeah, you can see it, it's already starting to squish out. I just glued this on a minute ago. Allowed it, the butt block itself, to allow the thickness of the wall, so I don't have to allow to the wall itself. I didn't want to allow to the ply, so I just took off 8 millimeters over here on the inside. Yeah, just like that, and then the rest I took it out of here. I used my router. I set it on 8 millimeters, the thickness of the ply, and I just went down. Perfect fit. Everything is in place, and it's very, very strong. Now, the reason I chose to do it that way is there's no way that butt block can ever lift up, because it's glued on with PU and not with epoxy. So just to be 1000% sure, it's now held by the chain log. The chain log is holding it in place from not ever moving away from there. And that's basically it. So now I'm going to put so now it's putting masking tape on the chain log all the way, and then epoxying this thing on and screwing it in. I'm going to use screws with washers, and this is how I'm going to tighten it down. It's I didn't want to put holes through underwater line, but there's no other way to get the bottom on. I mean, I can't think of it. You could tie ropes and bang in wedges, or I don't know what crazy stuff you could do, but the epoxy is not giving you time, you know. So I think it's the easiest way is to just screw it in. Then we'll fill the screw holes. We're going to have 200 and something grams of fiberglass on the bottom per square meter. There's going to be a lot of glass on the bottom, going to be bottom paint and stuff, so I expect it to last. And when the bottom goes, if the walls are still good, then the bottom can be changed. Whereas a wall, if I've got holes under water line that are giving me trouble and lot patches start, so you can't replace the whole wall, you'll have to just start fixing it locally. Whereas the whole bottom could be replaced. So I don't know, I mean, like, whatever, let's just see what happens. Hull's been sprayed clean with a compressor and masking tape everywhere, masking tape, and I tried to stick it on only at the top, so it's kind of flying in, kind of, and then whatever drips down there, doesn't dirty my boat. So, glued on bottom, 12mm, so I put it on with screws and washers. I'm starting to take them out over here now, and works well. Pulls it down nice and tight, all the epoxy squishes out. I really like banging in toothpicks. I put epoxy on them, and I fill the hole with epoxy. I fill, and then I bang it in. The point of this is I'm attempting as much as I can to seal the hole, the screw hole, to seal it. So if water does get in, and it probably will eventually, you're preventing the water from crawling around and creeping around into the ply and going this way and that way and everywhere. And then over here, up to here they are. They're way above waterline. Above waterline, I'm really not worried. Again, filled up with epoxy and twigs and whatever they call. I'm not worried because water splashes on there and it comes off. Whereas under waterline, you're always in there and water just looking for where to get through. I can change the bottom easier than I can change the side. That's another way I'm thinking, you know. So might as well change the bottom. Let's say if it goes rotten, then change the side. Changing a side is serious stuff. So the dagger, I'm going full-time experimental, and I'm testing this. I want to see what happens. So first of all, it's all glued up with PU, polyurethane. And then I blew holes in all the way through this dagger, everywhere. I just screwed it up with holes and everywhere, and there's holes all the way, under waterline, above waterline. The way I tighten this batten on, I'm going to tighten the next batten on again with screws. And I think bashing holes and putting screws through, you know, that's the stuff I use to tighten, okay? I'll put it over here and tighten down the ply. I think I can take this dagger out when I'm not sailing. It doesn't have to be in the water all the time, you know? So let's just go all the way experimental and see what happens with a dagger that is not even glassed. I'm even thinking about not even glassing him. I'll glass the edges again. The edges I will. Here's a perfectly good dagger, because I was thinking of glassing him until today. Today the penny dropped. Here's this dagger. I mean, this dagger's worked a lot. It's been in the water for 2 weeks at a time. 2 weeks at a time it's been, and there's absolutely nothing wrong with it. It's 4mm poplar ply, absolutely no glass except for around the corners, like I said, and it's worked really well. It's still good. It's perfect. It's dry. There's no water's getting in there, so might as well keep working that way. It's working. Whatever works we keep, whatever doesn't work we don't keep. Here's bows I've put on. This is strong, so I wet out with clear epoxy both surfaces. This is always, I glue wood this way. I wet out both sides with clear epoxy, then I put a lot of thickened stuff, I put it on, and I clamp it down with screws. These screws will get filled, and now this whole bow has to get planed and shaved into shape. And this is a strong bow because there's this much wood inside, So now there's this much of pine, which is, I don't know, about like 7-8 centimeters of solid pine, 8mm hull. So a lot of stringers over here. So pretty tough bows. So talking about bows now, I really like raked aft. I really like the way the bow works. I discovered this when I built Makeup Rake, and I like the rake. The good thing about rake, my first two pros, Crystal Clear and Why Not, had almost plumb bows. Almost, just a little bit, tiny bit of rake. And they had little flare. The more rake you add, the more you pull the bow back, the more you can flare it open, and then it becomes real nice, real cool. Yeah, I'll show you under the table, because that's the only view we have. And ignore the spider webs. And that's nice flare. I really like that flare. I really like this. It's the flare, the rake, the rocker. All this helps a boat in a rough sea. I always built boats for rough sea. Over here, this was a junk canoe that I built that I didn't like, but I had to check my Lashank. I needed a pro to rig my junk rig onto. So I just took out this junk canoe, which was only the blue part, and I had it on the top sides and I closed him up. He was very unstable because he's a flat bottom, very wide. That's a mistake. But as a pro with his little armor on the side, this boat can take a lot. It's a real good boat. You can load this boat so much, and it goes. It's pretty fast for what it is. So over here, there's almost no rocker, a lot of flare, and quite a big flat bottom. Whereas over here I'm keeping flat bottoms. I like flat bottoms. A lot of people going on about flat bottoms that they're not good. Yeah, they're not good. They make a wave. There's an ugly wave. As the water flows, it flows under and it twirls like this, and it gets all weird and stuff happens to water. Water doesn't like edges. Water likes a flow. So yes, I agree. I understand. You lose speed, you lose effectiveness, you lose. But you gain. You gain in simplicity, in fast build, in less material. I believe in a lighter boat and in much more volume. So I'm keeping on with this. I mean, like, I'm happy with all the flat bottom boats I've had. Crystal Clear wasn't a flat bottom. She was a V-hull. She was my first pro. She really worked well in the sea, actually. I remember that boat used to just like, yo, man. It was like driving a bus. You felt nothing. Big, ugly, black sea, chop, walls coming at you. You just flatten everything. It was an amazing boat. Narrow, nice, V-bottom, yes, it's good stuff. But I can't spare the volume. I can't spare the volume. And the simplicity and the fastness. That's a word. Make fastability, fastness. So the fastness of the build is to my liking.